The next example of PageRank that we will look at is the application to measuring proximity in graphs. So here is basically the idea. Imagine we are given a graph and we would like to measure some notion of proximity or closeness or similarity between nodes A and B. So the red node, the hexagonal node A and the hexagonal node B. And the question is, how do we do this? One way how to do this would be to use the shortest paths. So the problem with shortest paths is that, for example, in these two different cases, the shortest path computation would give me the same value. The distance between nodes A and B is the same, even though kind of in the second case, we could say because of all these dangling nodes, the proximity between A and B is smaller than in the first case. Another thing, for example, that happens when we are using shortest path to measure proximity of nodes in a graph is that if there are multiple separate paths between a pair of nodes, we don't really care about that. Even though, for example, here in the first case, intuitively, we would like nodes A and B to be closer to each other than in the second case, because in the second case there is only one path, but in the first case we have two different paths connecting A and B. So, for example, shortest path length between a pair of nodes may not be the best notion of proximity. Another thing we could do is, for example, to say how much network flow can be pushed between nodes A and B. The problem is that even this is not too good solution to intuitively capture the notion of similarity or proximity of nodes in a graph. The problem is here that we can have very long chains and they don't get penalized, right? So in the case I have here, both nodes A and B, we are able to push 1 unit of flow between them, even though in the first case we would intuitively say that nodes A and B are closer or more, their proximity is better than in the second case. So the problem with network flows is that it doesn't capture long paths. So the question is, what is a good notion of proximity? And if you think about the good notion of proximity, it would be a metric that would consider that there are multiple ways to get from one node to another, right? So that there are multiple paths. And another one is that it would also consider the quality or the weight of connections in terms of whether the connections are directed or not, whether how long are these connections, how strong they are, what is the degree of the node, and so on. And as it turns out, a good way to measure proximities in a graph is a method is called SimRank. And SimRank is basically a random walk with restarts from a single fixed node, right? And what is interesting is that SimRank was initially proposed where we have this, what is called k-partite graphs, where the idea is that we have different types of entities. Imagine we have k different types of entities, and now we create a k-partite graph where basically entities of one type are linking only to the entities of another type. So for example, we could create a graph where we have two partitions. One is a set of all the images, and the other one is a set of all the tags between the images. And now the idea is, how do we measure similarity between a pair of images? And one way to measure similarity between a pair of images is to basically do a random walk of restarts from one page and measure the proximity to every other page. What I mean by random walk with restarts is simply the personalized PageRank where the teleport set S is a single node, which is the starting node used. This basically means that the random walker can walk around the graph, but then always jumps back to our starting node U. So this means that the resulting PageRank scores will measure the proximity or similarity of any other node in the graph with respect to the node U. Of course, the problem with this is that this is not the most scalable method because it means that for every node we have to compute a separate set of similarities. So this is something that works well for kind of sub-web scale problems, but on a larger web scale graph, this may be too hard to do, and we don't want to have the teleport set to be individual nodes, but maybe sets of nodes, and then we are back to the personalized PageRank world that we talked about today. Just to show you an example of how this can be done is, imagine you want to measure similarities between different conferences. And you would, for example, like to know what are the most similar conferences to the conference of ICDM. ICDM is a data mining conference, very well known. So one way to measure these similarities would be the following. We would first create the bipartite graph of conferences and the authors that publish at these conferences, right? So every node here is a different computer science conference, and every node on the right is a different author, a different scientist, and we connect a given author and a given conference if that author published a paper at that conference. What we do now, for example, is we perform now a random walk with restarts from the node ICDM and measure the visiting probability of the random walker of all other nodes on my left partition. And what will happen is that we will basically obtain different scores of the nodes on the left. The idea here is, right, that two conferences will be close if they share lots of co-authors in common, if there is many shortest paths between them, and so on. Right? So if we actually do this and measure and ask what is the result we get, for example, here is my ICDM conference, and here is a list of conferences that are most similar to it. Here are the corresponding random walk with restart scores, and we see the KDD, so the International Conference on Data Mining, is the most similar, and then another data mining conference and another data mining conference. The PKDD is the European version, PAKDD is Pacific Asia conference on data mining, and then it's conference on machine learning and databases and so on and so forth. Right? So we get very intuitive results, but basically running the personalized PageRank on this bipartite graph, and this idea can very naturally be extended to other types of graphs and other types of entities.